everyone, BigStuff here. Welcome to another Gen 4 technical support video. So this video is really cool. This is one of the big differentiators of why the Gen 4 system is one of the best out there and one of the only ones that can do this technology. So the Gen 4 ECU came out around 2017, 2018. We're almost 8-9 years in now. And we're still one of the only ones that do closed loop technology per hole. And what that means is because our CAN bus is 100 megabit Ethernet, that is plenty fast enough to control each cylinder individually in real time. So what that means is that if you have a supercharged, naturally aspirated, nitrous car, you can individually in closed loop control each hole. It's really an amazing technology. For the price point of the BigStuff system, you will absolutely unequivocally not find anything near it for this technology. And we're going to go over into how it actually works here on the system. So the first thing I want to show you here is how it's actually laid out. Okay, so here's a Gen 4 ECU down here. This is basically, well, it's not everything, but this is mostly everything that can be applied to the Gen 4 system. Over here is the main engine harness. Over here is the fuel injector setup where you can have 16 injectors. But up here is where we go into our big band technology. Now the big bands, the way that they work is they have an O2 sensor per hole, which you can monitor. They also have an EGT sensor per hole as well. So these talk through a networking router. So the Gen 4 ECU comes standard with an Ethernet port on the side, which is how you can get a real Wi-Fi connection or be hardwired connection to the Ethernet port. But coming up in here, you actually communicate or work with a router. So this router is 100 megabit. The big bands talk 100 megabit speed over the router. So in real time, when you're going down the racetrack, the big bands are sending their data, their wideband data, at over 100 megabits a second. The ECU is able to process that, and then in real time, we adjust each fuel injector per hole based on the closed loop AFR target. It's incredible. So this technology will allow you to dial in an engine so fast on the individuals, because not like having an O2 sensor is groundbreaking on per hole at all is new. But because we give you the feedback per hole to let you be able to see in closed loop what it wants during the entire sweep, the entire pull, whatever you're doing, you can individually now fine tune all those cylinders incredibly fast. In every engine, there's going to be cylinders that are doing more work than the others. The O2 sensor will see that. You'll see a sensor that's showing leaner with the same fuel being applied in all of them. That's obviously doing more work. You got to put more fuel in that hole. You'll see some cylinders are run fat. They're getting more fuel shoved into them based on the intake manifold, the way the airflow is going. You got to scalp fuel out of those. This system will tell you exactly what to do because it tells you what it does per hole through the entire sweep. So you can literally dial in your individuals incredibly fast. So for an all-out race engine, it doesn't get much better than that, because why would you want to beat up on your engine any more than you have to, right? It's just amazing how fast you can get these dialed in. I do a lot of big cubic inch work, and probably within 3 or 4 pulls, we're done. Absolutely done, because we start with a good bass tune. The individuals will tell you exactly where they need to go, and you're done. At that point, hit the racetrack, you're done with the engine dyno. Then at the racetrack, you're going to reconfigure some stuff, because obviously the racetrack's going to be a different load than the engine, but it'll get you very close. You'll see exactly where you need to be. So if I come over here to a data log, let's start off with, in the AFR section, how this is configured, okay? So the first thing you want to do is over here in the closed loop type, you're going to have it set up for either dual or IC rim, okay? IC rim, this selection here, is what you would actually choose for choosing the individual rim modules, okay? The rim stands for remote interface module. You would choose IC rim. In this application, it's for Ford. If you had EGT sensors plugged into it, you would have the EGT units as Fahrenheit, okay? And then you would have your standard closed loop settings over here, the on thresholds, your coolant temperature thresholds, your gain settings, your step rich, okay? This is all covered in the manual, but basically the gain setting is how fast you apply the closed loop correction. And when you have individual O2 sensor correction, I recommend typically around a 10% gain, because your resolution is so much higher versus the dual. When you have one sensor looking at 4 cylinders, okay, you want to have something a little faster. But when you have one sensor per hole, that's too fast because remember, you're getting all 4 strokes on that cylinder, okay? So you typically want to have that a little slower. Step rich is 10%, step lean, negative 10%. That'll be fine, all right? You're also going to have this O2 and EGT configuration section. So this is where for each rim module, you can tell it what hole is which. So in this case, because it's a Ford, for remote interface 1, number 1, I want to go to cylinder 1. Remote interface 1, O2 EGT number 2, I want to go to cylinder 2, and so on. If you had a Chevy, you'd go 1, 3, 5, 7, and then 2, 4, 6, 8, okay? And the way you can double check all those is by unplugging the O2 sensor, looking at the app, and when it's actually running, you can confirm that the correct cylinder shows that it's not available for use, so that you actually know that the O2 sensors are in the correct holes, okay? If you were to throw engine RPM on a simulator and think the ECU is actually running, then you can unplug them without running the engine. You can verify it that way as well. But for most guys, I just say, hey, just run the engine, unplug them one at a time, and that way you can verify it. Always do that. You never assume it's right. Just a good way to just double check it, okay? Give us a shout if you have any questions on that. So let's look at a log here, okay? So what this is here at the very top here, this is engine RPM. You can see here that we have an AFR target of 12.428, okay? So basically about 12.5, 12.4. So what you're seeing here is engine RPM. There's our target. This is a drag racing pass. This is on gasoline. And you can see here that these are the O2s. Now, this is on the rev limiter. The O2 sensors are obviously going to go crazy on the rev limiter because we're misfiring like crazy. A ton of oxygen is going out through the exhaust, okay? So this is the O2 sensors obviously picking up on all that. The 3 steps released, and then off we go. Now, what you can see here is this is the O2 sensor per hole, okay? And then this down here in this window is the actual O2 correction that's being applied. So you can see here that different cylinders definitely want more than the others. Okay, now this is very close. If we look at cylinder 1, we're actually pulling about 0.5%. Okay, it's showing about 12.8 right now. Cylinder 2 is adding 0.8. It's showing about 13.0. Cylinder 3 is 12.26. We're actually pulling a little bit there. So you can see there in real time, we're pulling the fuel out of each hole. Okay, and we're trying to get as close as we can to our 12.4 target. Now you have to realize that because this is in real time, sometimes the O2 sensor is going to show a little bit fatter or leaner based on what the target is. But you can see here that based on the correction, we're very low for the holes, depending on where we have to get to. Basically we're over or under 5%, which is amazing. Now you can see here that at this point right here, the O2 correction is shutting off. That's because we had a rev limiter. That's what these little spikes are right here in order to shift. And now the rev limiter actually turns off because the O2 closed loop correction turns off because of rev limiting. We come out of rev limiting, and then they all turn on again. All right. So you can see here the wideness, if you would, as far as how the O2s are correcting per hole. Again, in real time, it's telling you exactly what it wants. And then you can come over here, and then this is high gear. Okay, and you can see here how at 7,000 RPM, we got a pretty decent spread going on here. We got some pulling 3% on cylinder 3. In cylinder 3, we're 12.2 AFR. On cylinder 6, we're actually adding 6% and we're 12.44. I mean, is this beautiful or what? So you can see how fast you can get your individuals dialed in here because with closed loop, it literally tells you how much you need to add to that hole. And so the goal is to tighten up the individuals so that the individual correction tables, so that the individual closed loop correction is not doing as much. Then if you want to take it out of closed loop, you can because you've dialed everything in and you can go from there. But just an amazing technology. I mean, if you look at this data here, you can see here cylinder number 4, okay, was actually adding around 10%. Okay, it got up there. Something was going on in that hole. Maybe during that RPM, RPM 8,000 RPM, maybe some fuel went away from that hole and it needed to get a little bit more punched into it because, again, the fuel's going to go where the fuels go at these RPMs, at the airfill. This is a boosted combo making about 15 pounds of boost. So again, the O2 sensor tells you where it needs to get, where it needs to go. And you let the big stuff take control. We add the fuel where it's necessary. Very powerful technology, works great with nitrous, works great with methanol. You just can't have it on a turbocharged deal. Every other application, it'll work just fine. Okay? So if I was to come down here and on this bottom bar here, I can hold down the left button key and then go from like this from left to right. Okay? Remember, our target was 12.4. So you can see here that the average for cylinder 1 was 12.37. Average for cylinder 2 was 12.5. Average for cylinder 3 was 12.8. Average for cylinder 4 was 12.56. Average for cylinder 5 was 12.6. Average for cylinder 6 was 12.37. Average for cylinder 7, 12.55. Average cylinder 8, 12.42. I mean, come on. Are you kidding me right now? This is right where it needs to be. The O2 correction is doing exactly what it's supposed to do. And it'll actually tell you that, hey, the average for that hole, we were actually adding a little bit of fuel. You can actually see on cylinder number 1, we were adding about 2% of fuel average. Cylinder 2, we're actually averaging about an average of 5%. So we were actually adding most fuel to most holes average-wise. But in cylinder number 8, that was when actually we're actually pulling a little bit. And with a small block Ford obviously being in the back, this is pointing towards the back of the engine. This is going to typically get the most fuel. So maybe in the individual cylinder fuel correct table, there was already a bunch of fuel being added, so it was actually pulling a little bit of fuel out. Again, the goal is to get you into this individual cylinder table to start plotting what it wants so you can get this correction down. You can leave it to where the O2 correction is always running and it just does the work for you, but you want to start feeding the tables. You want to start building the tables individual-wise so that it's not correcting as much. You want to start getting really advanced, then you have a map per gear setup so that as you're going down the track, you're switching maps per gear, and then you're going to have individual fuel tables per gear with Spark. And there you can really fine tune it because throughout the RPM range through each gear, the load is different. The AFRs are going to read different. So as you go down, you'll have a set of fuel tables and Spark tables that you can manipulate per gear. I mean, it's unbelievable how tight you can get these air-free ratios and make these motors happy. We have so many customers that are just running incredibly fast with this setup because it's always doing the work for you. So we love this technology. We think it's great. This is actually from one of our good customers, Bob Gruber. This is Nick over Shoot Car Shenanigans. This is one of his passes recently from Sick Week. Nick did a great job tuning the engine. This is his calibration. And as you can see here, it wasn't correcting very much going down track. But you can see with the technology how it works and how awesome it works. I mean, it's you can just see in high gear, again, there's number 3 adding 13%. There's number 4 adding 10%. And you can see up here, number 3 was at 12.6. Number 4 was at 12.5. You can't do that on any other system at this price point. You can't. You won't find it. It's just impossible. Plus, we make all of our stuff here. Sorry, I got to make a dig here for everybody else that doesn't. We make all of our stuff right here. So, if you have any questions about this, if you want to know how this works, by all means, go check out our website, BigStuffTPM.com. We have an awesome tech section that goes over all this, but just an amazing technology, dollar for dollar. You won't find this anywhere else at this price point. Actually, I don't know anybody else that actually does this. So if anybody else out there with the other quote unquote advanced fuel injection systems, if they have this technology, I'd like to see it. And if they do, great. I've just never seen anybody show in real time this closed loop correction like this. We've had it almost 10 years now. When the Gen 4 first came out, the Ethernet port was standard. So Ethernet port have been on other systems as well, but you're probably talking a 5x multiplier cost-wise to get into their systems versus us. So, we're always looking out to be price conscious, but we also want to deliver a killer fast system as well. When it comes to our data logger as well, we also, for all this technology, we have a separate side of the ECU which gets all this data. So it's able to interpret it, it's able to write it, and not even break a sweat speed-wise. So if you have any questions about this, please give us a call. Again, whether you're naturally aspirated, you're a bracket car, you're an engine developer, you have methanol, you have E85, we don't care. It will work in any case, typically, except for a turbocharged deal where the O2 sensors will see back pressure. That's the only time it won't. If you have open zoomies, if you have standard headers going into a standard exhaust system, this will work just fine. Got to remember too, you'll also have the dual sensors as well. So you'll still be able to get all 10 O2 sensors in, and so you'll be able to look at your duals, but you will be correcting closed loop per hole with this setup. So again, amazing technology. Anybody that has it loves it. It's awesome when you get the data in for the first time and you really just can't believe what you see, because a lot of times a lot of guys won't have the O2 sensor technology per hole. And I remember actually when Nick was first working on this, and he told me he couldn't believe what he saw at first per hole. And it was true. I mean, you're going to have some holes that are just crazy lean. You won't know it because you're looking at an average of 4 cylinders typically on the bank, but you won't know that that cylinder is that hot or that lean. And with this, it'll tell you right away. And that's why I say it's basically cheating, because when you get into it and you see how the curve is being plot, okay, I know that I need to go into this cylinder number 4 table, and starting at around 7,000 RPM, I got to give this sucker some fuel. Okay, right there about 5%, but going over 7,000 RPM, I got to give it fuel. It gives you your fuel curve. You can see here, peak torque for the most part is probably somewhere around, or peak power is probably somewhere around 8,000, because most of them start to lay over a little bit past that, and they start to get straighter. But that also depends on how Nick has also calibrated the individual fuel tables, because if he's got that curve built in, at some point past peak power, you're going to start pulling some fuel out. You can always add some timing back in once you're past peak power. But you can see here that the air-fuel ratio gets pretty flat. So this is very close. Again, on this run here, it's good. It's a good example of knowing, okay, we got to add some more fuel to cylinders 3 and 4. They need fuel. For whatever reason, the fuel's going somewhere else. Maybe it's going number 8, and that's why 8's pulling fuel. But when you get the data and you see it, it just talks to you. It tells you exactly what to do. So we love this technology. We were the first ones to come out with it at that time. Again, we still don't really see very many competitors that offer this, but we'd love to help you out. We think it's a great tuning tool. We guarantee you'll cut your calibrations probably in half, especially when you have the O2s per hole to really fine tune the engine. Our bank closed loop setup as well, if you're going bank to bank, we do an average of all 4 holes, obviously, for the 1 cylinder, and then we control that bank. So when we're in closed loop on a bank sensor, 1, 2, 3, 4 in this application will all be going up or down, plus or minus whatever closed loop is. 5, 6, 7, 8 will all be going down. Other manufacturers do it differently. That makes no sense as far as what we see other guys doing. I think some other manufacturers average stuff, or anyways, it makes no sense. If we have an O2 sensor on that hole, we're going to control those 4 injectors on each side of the engine. So any questions, please give us a shout. We love this technology. Once our customers get this in their hands and we show them how to use it, it's just, the pearly gates open up and the data starts coming in, and they love it. So give us a shout if you have any questions. Please check out our website, BigStuffTPM.com. You can check us out on our socials at Facebook and Instagram. Give us an email, support@BigStuffTPM.com. Thank you for checking out this video, and please reach out to us with any questions, and talk to you soon. Thank you.